This is the difference quotient, something you're going to be using a lot in calculus. And so let's take a look at it. So what is the difference quotient? It's this. So it's a subtraction between two functions and you're dividing it by h. Well, what it really is this. If you have y2 minus y1 over x2 minus x1, this is your slope. So if we say that our x2 is equal to x plus h and our x1 is equal to x, then this would give us our y2 is f of x plus h, and our y1 is f of x. So plugging those in, we get f of x plus h minus f of x over x plus h minus x. Simplifying it, you get the difference quotient. So all it is a slope. It's a slope formula using functions. And so we're going to actually find what this difference quotient is using this. So you have some line here, and what we're going to do is create a slope formula. That's our difference quotient. It's basically the slope of a secant line between any 2 points. And I'll explain all that with a graph at the very end. But all you need to do is be able to find it right now. So our formula says that we need an f of x plus h, an f of x, and an h. Well, we already have the h. That's just the letter h. And we already have f of x because it's sitting right here. So we just need to find f of x plus h. So all we do is we plug it in. And so if you remember, we place a parenthesis for each variable, and then we substitute the x plus h. That's it. And we end up with 3x plus 3h minus 4. So now it says we're going to take the f of x plus h and subtract f of x. And I like to do this in parts. So we're going to take the f of x plus h and subtract f of x. And you don't have to even write this out. This is just subtracting. So we're taking 3x plus 3h minus 4. And we are subtracting from it the f of x. So we're taking this and subtracting this. And you don't distribute, you don't do anything, you just subtract. So we're taking away a 3x, like that, and we're taking away a negative 4, leaving us with just plain old 3h. So now if you introduce the h like this, we end up with 3h over h, and then this h at the bottom is always canceling. That's our main goal here. This is our goal, is to cancel the h, which gives us 3. And so like I said, this is the slope formula. And if you go back, this is just a line. And what is the slope of a line? It's 3. And so what's the slope we got? 3. It matches. It's exactly what it should be. Now, when you're dealing with this is a quadratic, it's going to give you something different. So that something different can be looked over here on our Desmos. So if I scroll out, you can see it's a parabola. It has x squared as our starting point. So let's find the difference quotient using this thing. It's not going to be a given. So as you can see, if I change our h value, that's the distance between the 2 points. That's all h represents. So this right here is x. So that would be x comma f of x. And this is x plus h. So that's f of x plus h. All right, a little confusing, right? All right, so we take f of x plus h because we need to find it. And so we plug that in for each x. And then we do have to simplify. So if we multiply this out, this is x plus h times x plus h. And so we end up with x squared plus xh plus xh plus h squared. So that's x squared plus 2xh plus h squared. And if you've done this enough, right, this is just a square formula. You get x squared plus 2xh's plus h squared. And then we distribute the 4x. I don't need a parenthesis if I distribute 4x minus 4h. And so that is f of x plus h. So now we need to find, let's move over here. We have f of x plus h minus f of x. That's our top. So if you look at our formula, it's f of x plus h minus f of x. And then we'll divide it by h. So we do this in parts. So what we're now going to do is just look at it. I don't want to write it all out. Our x squared, our 2x h plus h squared minus 4x minus 4h are all going to be subtracted by these two. So all you have to do is go, okay, well that x squared will cancel that x squared. That 4x will cancel that 4x. And what I'm left with for f of x plus h minus f of x is 2xh plus h squared minus 4h. Everything with an h, because that's where it was introduced, is here. The other numbers, the x squared and the 4x, are just appearing again, see? But everything else has an h. Now we know we're going to divide this by h. And so each term will now be divided by h. So it's this one divided by h, this one divided by h, and this one. So our difference quotient becomes 2x. We just take away 1h from each. And there you go. So this is our formula. So let's just say how it works is this. You have f of x, right? And you have f of x plus h. So you have two numbers you're plugging in, x, comma, and then there's a y value, and then x plus h, comma, and then there's a y value. So if we pick 5 for our x, and we say our h equals 1, then this would become 5 plus 1, which is 6. Now how do you find the second number? That we're just plugging into our function. So if we plug 5 into our function, you get 25 minus 20, which is 5. And if you plug 6 in, that would be 36 minus 24, which is 12. So if you look at the graph here, if I move this back to 1, that's why we lock it at 1. There we go. You can see we're going from the point 55 to the point 612. That's our points. So that x plus h means we're starting at 5. That's our x value. And we're adding a unit 1, an h, which would now give us 6. And so if I plug 5 into the function, I get 5. And if I plug 6 into the function, I get 12. So that's all our formula represents. And it's our slope formula. So all it is y2 minus y1 over x2 minus x1. And you can see our h here is 1. It's the difference between the two. That's it. That's what our h is. It's the two x's, the x plus h and the x. And then 12 minus 5 is 7. So that gives us a slope of 7. And you can see with the difference quotient, it gave us the 7. So it's a formula that pops out slopes of the secant line all the way through. So I can move this anywhere I want now that I have a formula. And I can see, okay, well, going from this point to this point, my slope is 7.8. And my difference between the two is 1. If I make it a difference of 2 away, so it's 5.4 to 7.4, my slope is 8.8. So that's all this is. It's a slope formula. And so getting used to this formula and using it now is good. So you have linear that you're going to deal with. You have quadratic, and they work exactly the same way. And then you also have rationals. And so this one is a little bit harder. Not much, but just a little bit. So when we plug it in, we have to do the top and the bottom. So we put an x plus h here and x plus h here. The difference on this one is it's not going to just cancel like we did with the quadratic and the linear. You do have to do a slight little modify. It still will. So now we write f of x plus h minus f of x, and we write it out. So this is x plus h plus 3 minus x over x plus 3. And then we divide the whole thing by h. And so here's the trick. What you're going to do is put a parenthesis on the top and a parenthesis on the bottom. This is our complex fraction. And you're going to multiply top and bottom, if you remember doing this before, by x plus 3, x plus h plus 3. And so this will distribute. So what I like to do is just put another one over here. And what that does is allow us to cancel it. So the x plus 3 will cancel. The x plus h cancels. And we end up with x plus 3 times x plus h minus x times x plus h plus 3. Now don't distribute the bottom. If you remember, our main goal, like I said, is to cancel this h. So all this tricks that we're doing right now is just to cancel that h. So we now have this. Looks horrible, but it's just a quick little distributing, and once you distribute, it will turn into like we had here, where things start to cancel. You'll see. So we get x squared plus xh plus 3x plus 3h, and then we distribute that, minus x squared minus xh minus 3x. And these are very self-checking. So everything without an x, without an h, should cancel, see? 3x. And so what are we left with? Oh, the xh's actually canceled too. So what are we left with? 3h. But this whole thing is still over this whole thing. So now we end up with 3h and now you can cancel the h. Remember, this was our goal. So all that work was just to do that little cancel. And there's exciting stuff coming with this. But all you have to do now is you have to settle for just being able to do this. Don't distribute the top, the bottom. It just becomes worse looking. So we end up with that. That is our difference quotient for a rational. So every single linear will work the same way. Every single quadratic will work exactly the same way, and every rational will work the same way, same exact steps. So you're just practicing this stuff right now. That's it. You're practicing how to do this. If you want to kind of look at it again and try to really think about it, that's great. That this is the x. This is our x plus h. So this is our x, and so that would be f of x. And this is our x plus h, and so that would be f of x plus h. And then down here is our h, so you can see it is 2 units away from each other. We're at 5.4, it's 7.4. So plugging 5.4 into the function, we get this, plugging it in. And then this slope is our f of x plus h minus f of x all over h. Remember, these two just cancel. So that one and that one, if you were to subtract it, the x's would cancel, leaving us with just h on the bottom. So it's just a slope formula. That's all it is. So this is a different way of looking at it. This is still a difference quotient, but we're now writing it more in slope form. It's not a standard, but they still do use it a lot. So it's f of b minus f of a, take away b minus a. We can basically put any letter we want in there. We're just saying that this is our first point, and this is our second point. So we have the point a comma f of a and the point b comma f of b. If you remember, our functions are the y values, and so putting it together we get the slope. And so it'll work the same way. We already know that this f of b minus f of a over b minus a has to equal 3, because that's the slope of our line right there. But we're going to still find it. So first we need f of b, so we plug that in. And we need f of a, so we plug that in. That's an a, not a b. And then we subtract. So the top says we're going to take our f of b, subtracting our f of a, and then we divide that whole thing by b minus a. So you'll see why this is less preferred. It's a little bit trickier. All right, so we get 3b minus 3a. And how do I get that? It's that same basic idea. 3b, take away 3a, and then it's -4, take away -4. Well, those are the same things. So we already know the -4 and the -4 will just subtract. And then this whole thing is over b minus a. So when we get this, what we need to do now is factor. So the top has a common factor of 3. And you'll see now that they cancel. And our answer is 3. So you may like this better than the other one, and honestly it doesn't matter which one you use. They both work perfectly fine. They are both difference quotients. My favorite is the f of x plus h, which is why that's what we did 3 examples of. And but you can also do the f of b minus f of a over b minus a. They will both give you the same answer. All right. Well, sort of the same answer. This one will have an h in it. This one won't. So, all right, thank you. But wait, I gotta just say it. So remember, our h here is just the bottom. It's a subtraction of the two. So our h here is b minus a. That is our h right there. That's our h. All right, thank you.